Hello, my name is Gregor von Laschewski, and I'm talking to you today about high-performance computing and especially the use of queuing systems on FutureGrid. The easiest way to follow this tutorial is to also look into our manual that contains a very special section about HPC services that you can locate and try to execute via paste and copy some of the exercises that we do today. Thank you very much. So let us now consider the manual, and we need to be locating a section called HPC Services, on which we find a list of the machine names on which we can execute high-performance computing jobs via, for example, MPI. And we need to be logging into one of these machines, and we can use for that our usual SSH command. So let me just copy this command. Naturally, you should be using your own username instead of the portal name. In my case, this is Albert. This is our sample user. So we are logging in. And the first thing it does is it adds this particular machine to our authorized host keys. This is a security measure so that you know that you have been logging in there and that you want to log in into such a machine. And now we are logged in into the machine, Sierra. And we need to be figuring out what is actually available on the system. For that, we have a modules program, and that can list us the available modules. So let's just list them. We type in module avail. And as you can see, we have many modules available, but the ones that we need are actually the two Moab and Talk modules that we have already listed here at startup. I highlight this right now. So we don't have to really do anything, but we need to be also adding a compiler so that we can compile programs. And for that, we need to be deciding which version of MPI we are using. There's a table associated with this in our manual that lists the available MPI versions. So we just go there. We can see that we have OpenMPI available, and I'm just using this in this particular case and load the OpenMPI module so that we have access to that particular compiler. Now next is we need to have a program that we need to be compiling. We have a simple MPI application in our distribution. It's a ring program. It's a standard MPI program that simply sends messages between servers. We copy the file. We open an editor on that particular Sierra machine, which in my case is I like to use Emacs. I paste and copy the text from our program ring.c and save it to ring.c. So that's all I have done. Is I just copied the program, and now I need to be executing this particular command or program better with the compiler. I simply say mpi cc -o ring.c. Here I have now created the program. Don't mind the error message. This is in this particular case normal. We will be correcting this in the future version of our deployment so that this warning does not appear. The program will work anyways. So we see when we are looking at ls ring, the program is being created. But in order for us to submit it to a queuing system, we also need to have a script that actually submits this particular job to a queuing system. So let me copy a sample of such a script. So that's what I'm currently doing here. I just copy this into a file called ring.pbs. Here we have a whole bunch of commands that are related to the queuing system that controls the behavior of the queuing system. We also have to make sure that we are running the same version of MPI that we are using when we compile the program. So I load the module OpenMPI as part of the script. And then we need to be running our program on several nodes. This is specified by the MPI run program. Here we are just specifying 4 nodes. Once the job is completed, it sends an email out to the user specified. Here I don't want to send an email, so I just delete this. And then the most important part is we need to be submitting it to a particular queue that has been specified minus the -q option. How do we find this now out? Well, the best thing is to consult just with the manual and browse through. Or if you're tired of browsing, you can maybe look for the keyword batch, because batch is one of the queues that I know have been defined on Sierra. So let us just start the search for it. Well, we see lots of matches. Let's just go through the matches and locate the right position in the document. And here we can see, yeah, there's lots of batch queues defined on India and Sierra. And as you can see, both have a batch queue. These are two different queues for two different systems, but they're sharing the same name. So let's just put batch in. This makes it also possible to use the same script on multiple machines, so you can log in first on Sierra and then log in to India and then execute the same program with the same batch script. So what we need to now do is we need to be submitting this particular program. So let's search in our manual how to do that. I will be having to find a qsub command. As you can see, qsub submit. We just execute qsub on that particular batch script we have just defined, and we execute this. And now we can say qstat, and then we see, for example, our job Albert in that particular queue. And as you can see, there's a lot of jobs are being submitted currently in our queue. And there's a second command to take a look at our system. That's show queue. Show queue is letter Q. Let's type it in. It shows a little bit more nicer view of it. And as you can see already, our job no longer appears in the job queue, so the likelihood that it's done is pretty high. So let's take a look at our system. So let's take a look at ring star, and we see a standard error and standard out. And when we take a look at the output, it will actually give us the output that has been created by this particular program. And the way we created that particular name was through, for example, a queuing system script. And that's all there is to know in order to start a job and view the output after you're finished with it.